Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May-June 2023 paper 2 variant theory. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. In this lesson, we will only focus mechanics part, mean we will discuss first half of the paper in today's lesson. And in tomorrow's lesson, we will cover remaining half of this paper. Let's study together. Let's improve together. In today's lesson, we are talking about May-June 2023 paper 2 variant theory. Total time for this exam is 1 hour and 15 minutes and total mark for this paper is 60. You need to answer all questions in this paper. And if you look at grade threshold and if we compare these three variants, you can see the grade threshold for variant 2 is higher than variant 1 and variant 3. It simply means that variant 2 is relatively easier than variant 1 and 3 are. Students, they performed well on variant 2 as compared with variant 1 and 3. And also if you look at overall means A-level grades, grade threshold this year was much higher than past years. It also tells us that this year papers were not very difficult. So that's the reason grade threshold is bit higher than past years. On second page of your exam paper, some data is given to you. Mean values of some important constants are given to you. If you need value of any constant, you can come to the second page and you can find value of constant. And also on the second page, some important formulae are also given to you. If you have forgotten any formula, means basic formula, you need to double check or you need that formula, you can also come to the second page and you can find some important basic formulae. But these formulae are not all the formulae you need for AS exam. Before we start over question 1, let me explain you a little bit something about life. And so what is life? You can take some time and try to answer by yourself what is life. Then I will answer this question. Life is the creation of your mind. Means your thoughts are very important to develop yourself, to be happy or to do anything in your life. Your mind is very important. Your thoughts are very important. Your life is driven, or simply we can say is created by your thoughts. So it's very important what you listen, what you do, and what you watch in your life, because these things will change your thoughts, means they will upgrade your software. So listen good, say good, and watch good. In this way you can be a positive person, you can also be a well disciplined person, and you can progress in your life. So your thoughts, everything is your thoughts. Question 1 says, a well has a depth of 36 meters from ground level to the surface of the water as shown in figure 1.1. The student wishes to find the depth of the well. The student plans to drop a stone down the well and record the time taken from releasing the stone to hearing the splash made by the stone as it enters the water. For part A, we can assume that air resistance is negligible and that the stone is released from rest. Means we can assume there is no air resistance and the stone is released from rest. For part A, we need to calculate the time taken for the stone to fall from the ground level to the surface of the water. Means simply we need to calculate time taken by stone to start from this point, and at this point stone is at rest, to this point, the time taken by the stone. And in this case there is no air resistance and vertical displacement is given to us. So simply this is uniform acceleration motion, because in this case when the stone is falling there is a constant force acting on the stone, so it means acceleration is constant resultant force acting on the stone. So simply this question is about kinematics. So we can say S is equal to ut, we need to find the time, 1/2 a t square. And in this case A is equal to G, because the stone is in free fall, there is no air resistance. And it is also given to us this stone started from rest. Started from rest, it simply means that u is equal to 0. So it means this term is equal to 0. Now simply we have s that is equal to 1/2 a, we can replace with g, and this is t squared. So in this case we are taking down is positive. Down is positive, so the displacement is positive, g is also positive. So we need to calculate time. So time simply will be equal to 2s divided by g and root of this one. So we have value of s, vertical displacement, that is equal to 36, and we need to divide this one by value of g, that is 9.81. and now if we take square root of this one, the time we will get, time is equal to 2.7 seconds, and our answer is up to 2 sf, because the given data we have, that is given up to 2 sf, means the least number of data in raw data we have, that is equal to 2 sf. So the final answer also has to be up to 2 sf. And this question has 2 marks. The first mark you will get if you have written this formula. If you have written formula, you will get 1 C mark, and the second mark you will get, that is the answer mark, if you have got the right answer. If your answer is right, if you haven't written formula, still you will get 2 marks. So the final answer is 2.7 seconds. A beautiful question. Try to understand the concept in physics. This question is easy, but it's not meant simply you use the formula. You need to understand why we're using this one. So the stone is falling with uniform acceleration, so we have the displacement, we have value of acceleration, so we can use this formula. So visualize, physics is a way of thinking, so you have to develop that way of thinking. Part B says the time recorded by the student using a stopwatch is not equal to the time in A, means time calculated in part A. Suggest 3 possible reasons other than the effect of air resistance for this difference. So first thing we need to understand, in this case, when students start the stopwatch, at what time he has to start the stopwatch? So he has to start the stopwatch when he just dropped the stone. So maybe he couldn't start stopwatch at the same instant of time. So this can be the reason. The second reason can be when students drop the stone, maybe he has applied little force on the stone, so stone has some initial velocity. And it is also possible stopwatch has 0 error. So the time recorded by the stopwatch, that is different than the actual time taken by the stone to cover 36 meters. And it is also possible when the stone hit the water, student will hear the sound, and as soon as student hear the sound, student has to stop the stopwatch. So maybe due to reaction time, student couldn't stop the stopwatch at the instant when he hears the sound. So that can also be a possible reason. So these are the possible reasons. Now let me show you the answer, how you can write down your answer. So in your answer you can mention these points. You can say reaction time between hearing the splash, mean the sound, and stopping the stopwatch. Student might not let go of the stone and start the stopwatch at the same time, and stone given initial velocity, means when he dropped the stone he has applied some force on the stone. And we can also say stopwatch may have 0 error. Stopwatch has 0 error. So this is also possible. So these are some possible reasons. For this question, simply you have to write down 3 points, and if you write down the first one, you will get 1 B mark. If you have written the second one, you will get another B mark. If you have written the third point, you will get another B mark, and if you have written this one, you will get, in total you will get 3 marks. Part C says the student repeats the experiment 3 times and uses the results to calculate the depth of the well. The values are shown in table 1.1. The true depth of the well is 36.0 meters. Explain why these results may be described as precise but not accurate. Precise and describe. So first thing we need to understand, if we look at these results, we have 54.4, we have 53.9, we have 54.1, and the true value of depth is given to us, true value. true value is equal to 36 meters. So we need to understand the meaning of precise and we need to understand the meaning of accurate. Precise means that precise. What is precise? Precise means that readings are close to each other, or simply we can say the measurements are close to each other. So we can say measurements are close to each other. This means precise. Measurements are close to each other, close to each other, close to each other. So very important one. So what you need to understand is one thing you need to understand: close to each other. So this means precise. And the second thing we need to understand is about accurate. Accurate, exact. So we can say what is meaning of accurate. This term is very important. Accurate means that measured value, or we can say the measurements, measured value, or you can say the mean value is close to true value. True value. If close, it means result is accurate. But in this case, if we calculate, for example, the mean value, let's try to calculate mean value first of all. Mean value, so you can have better idea about this one. Mean value, we have 54.4 and we have 53.9 plus we have 54.1 divided by 3. So if we calculate mean value, this will be about equal to 54.1. Now simply we have to compare these two values. Means the mean value we have to compare, this is 36.0. So simply we have to compare now 36.0 with 54.1. So are these two values, they're close to each other or not? If 10% difference, it is acceptable, but this is more than 10%. It means that this result is not accurate. So we will say result is not accurate because mean value is equal to this and the true value is this, and these two values are not close to each other, so it is not accurate. But this result is precise because these readings are close to each other. So this is the main concept you need to understand. Now let me show you the answer, how you can write down the answer. So in your answer you can mention these points. Now for precision, you can say results are close together. You can also write down, instead of results, you can say 54.4, 53.9 and 54.1 meter. They are close together, close to each other, so it means these measurements are precise. Then you can say these values are not close to true value, and the true value in this case is equal to 36.0 meters. And the values you can also say here, you can also mention mean value, that is equal to 54.1 meter. This is not close to 36.0 meters, so it means these measurements are not accurate, but these measurements are precise. So this is how you can answer. Question 2 says a sphere floats in equilibrium on the surface of seawater of density 1050 kg per cubic meter as shown in figure 2.1. For part A, it is given to us that 21% of the volume of the sphere is below the surface of the water, and we need to calculate density of the sphere. So it's a beautiful question just about upthrust. So first of all, if we draw the free body diagram, so we can draw the forces acting on the sphere. Is the weight of the sphere that is acting vertically downward, means the gravity, and there is upthrust on the sphere that is acting vertically upwards, and these two forces are balanced because this is in equilibrium. And upthrust is equal to mass of the water displaced times g, mass of the water displaced. And mass of the water displaced we can say is equal to density of the water times volume of the water displaced times g. And this one we can say this is mass of the sphere, so we can say this is density of the sphere times volume of the sphere times g, and these two forces are equal. And it is given to us that 21% of the volume of the sphere is inside, 21%. So it means that VW, volume of the water displaced, This is 21% of the volume of the sphere, means 0.21. So this is volume of sphere, means the total volume. And these two forces are equal, so simply we need to equate. So we can say in this case we have density of the sphere times volume of sphere times G. This is equal to density of the water times volume of the water times G. So from here we can cancel G with G. We have to calculate density of the sphere. So this is equal to density of the water. So we can say this is density of water, volume of water divided by volume of sphere. Now we can plug in values. Volume of water displaced, this is mass of water displaced, very important, so you have to be clear about this part. Water displaced means mass of water displaced. So in this case we have density of water, that is 1050, and we have volume of water displaced, that is 0.21 times Vs divided by Vs we have. So Vs cancel, and in this case our final answer will be equal to 220 up to 2 SF, because the data is given up to 2 SF. So this is our final answer. So up to 2 SF, so this is our final answer. So this is how we can answer this problem. So this question has 2 marks. The 1 mark you will get if you have equated these two, you will get C1, and the second mark is the answer mark. So this is answer mark. Part B says the sphere is now held so that its entire volume is below the surface of the water. The sphere is then released. For part B1, calculate the initial acceleration of the sphere. So the best way to answer this question is, first of all, we can imagine that the water level is higher than the sphere. So simply you can imagine the water level is until here. So it simply means that this sphere is fully immersed in water, means fully inside the water. Now if we consider the forces acting on this one, so we will see in this case there are 2 forces acting on this. One is mg, the weight of the sphere, that is acting down, and there will be up thrust, and this up thrust is now greater than mg. So this one is the up thrust, simply we can say this is u, and this one will be equal to the mass of the water displaced times g. So we can say this will be equal to the density of the water times volume of water displaced times g, and the mass of sphere, the weight of the sphere, this will be equal to ms, and we have in this case g. So m we can write down in form of rho s vs times g. But now the question is, what is the volume of water? In this case, this is fully immersed in water, is fully inside the water. So this is the tricky part. You need to understand, in this case, volume of the water displaced, this is equal to volume of sphere. So in this case we need to calculate acceleration. So simply for this purpose we need to understand F net, means by Newton's cycle law. F net, this is equal to ma. So what is F net? Means up thrust minus weight. So up thrust we have, that is equal to rho w times v, we can say this is equal to vs times g, minus we have this is rho s times we have vs times g, and this is equal to the mass of the sphere, and mass of the sphere is equal to density of the sphere times volume of the sphere times a. Now from here you can simply cancel vs, this is common, so we can cancel this one. We can cancel this one first of all. Now we left with, this is density of water times g, minus we have density of the sphere times g, and this is equal to density of sphere times a. So we need to calculate a in this case. So simply we have, this is density of water times g, minus we have density of sphere times g, divided by density of sphere. Now simply we need to plug in values. Density of water we have, that was equal to 1050, and we have g, that is equal to 9.81, minus density of sphere we have calculated, that was 220, times 9.81 divided by density of sphere, that is equal to 220 kgs per cubic meter. Now if we solve this one up to 2SF, we will get 37 meters per second per second. Very high acceleration, means it will just shoot up with this acceleration. So very high acceleration. So this is how we can calculate. And this question has 3 marks. And the first mark you will get if you have written this formula. You will get 1 mark, C1. And the second mark, if you have plugged in these values, you will get the second C mark. And the third mark is the answer mark. If you have got right answer, you will get 3 marks. A beautiful question. Part 2 says the sphere accelerates upwards but remains below the surface of the water. State and explain what happens to the acceleration of the sphere as its velocity begins to increase. So now in this case, again, we need to imagine that this sphere is in the water. So it is accelerating upwards, but it is still in the water. So if it is still in the water and it is accelerating, so we can draw the free body diagram for that one. So we have already discussed that there is a force acting on this one, that is downwards, that is the weight of the sphere, and sphere is accelerating upwards in the water, so there is drag force by the water. So we can write down there is drag force, we can say this is Ft, and there is upthrust that is acting vertically upwards on the sphere, so this one is upthrust. For the drag force, we need to understand as the speed increases, drag force increases. It depends on the speed. So as speed will increase, drag force will increase. So as speed is increasing, drag force is increasing. So how about the net force? So we can write down here F net. This is equal to upthrust. Upthrust in this case is constant. So upthrust minus we have mg plus we have this is the drag force. So as sphere is accelerating upwards, drag force is increasing. Weight of the sphere is constant. Upthrust is constant. So in this case, F net is decreasing. And if F net is decreasing, we can also write down here F net, this is equal to ma. So if F net decrease, it means acceleration will decrease, but velocity will go on increasing. So these are the points we need to understand. One point we can say in this case, drag force increases with speed, so the resultant force will decrease with speed, and acceleration will also decrease. So we can say this is point 1, second point, this is third point. So we have to write down 3 points. So this is how we can answer. This question is a typical question. Sometimes they will ask you, a ball is dropped in the air, so how the acceleration of the ball will change. And in this case, ball is given to you, means the sphere is given to you, that is in the water. So you need to understand how to answer this type of problems. Let me show you the answer, how you can write down your final answer. So this is how you can write down your final answer. In your final answer, you have to mention these 3 points. This is M mark, mean it has to be in your answer, means downward drag force increases with speed, resultant force decreases. This is also M mark. This has to be in your answer. And the last mark is acceleration decreases. This is the answer mark. If you couldn't get these marks, M marks, you will also not get this mark. So that's all for today's video. We have discussed 2 very nice questions from mechanics, and remaining questions from this paper I will try to upload by tomorrow. And if this video was helpful, please like and subscribe, because your encouragement is very important. See you in next video. And also, if you have any questions, please leave your questions in comments and I will try to answer as soon as possible.